And we, the LKR, in English LMT, Light Metal Technologies, we are sitting here in Ranshofen, and we are dealing with light metals. So Light Metals Technologies Ranshofen is a part of AIT. We are part of one of the centers of AIT. We are part of the center of low emission transport. So our main goal is to investigate, to introduce new parts for industry, for airplanes, of course, for car industry, which helps to reduce the emissions.
The main challenges aircraft design faces is that traditionally you take certain materials, you try to make them as high performance as possible, be it aluminum, be it titanium, be it CFRP, and only then you think about how to assemble it. That means basically modern aircraft design means you have high-class, high-performance materials that are being riveted with a huge bunch of steel rivets, so they are fixed together basically, and that makes the aircraft. That brings a problem as soon as you try to dismantle it, because usually it is not really possible to separate all the high-performance materials and put them back in a recycling environment where they can regain that high-performance property.
We start directly at the design phase of a component of the airplane by thinking not only with the first life material how we can go through till the end of life of this material, but rather more we also think about what will happen when the end of life is reached and how we can recycle it to give this material a chance for a second life, to go the circle around in another way. Vision, our goal will be that we introduce technologies from the car industry, like high pressure die casting, that we can then manufacture components for aircraft with material parameters very similar to other aluminum alloys, and then directly using them in SUSTAINair. And
main attractive thing about casting, so shape casting, any material is cast, but when we talk about shape casting like you do in high pressure die casting, you get out of the machine, you get the part as is or almost net shape. So you don't need to do any milling, any cutting, anything like that. You just use as much material as you need to create the structure. Whereas in the traditional approach, when you take an airframe, for example, so the circular frame that holds the structure together, that is being milled from a huge plate, meaning that you have a loss of material in the magnitude between 80 and 95%, which is huge, and a huge amount of energy that is being wasted, basically, from a sustainability point of view. By casting, you can just assemble it in single pieces that are net shaped and just use as much material as is required to create that shape.